This is lesson 3-4, ratio and proportion. A ratio is a comparison of two numbers by division. It can be written in one of three ways. Any of the following ways are fine. You can write it A to B with words, A to B with a colon, or as a fraction, A to B. It does not matter how you write it, they are all said the same way, A to B. A rate is similar to a ratio because it is a ratio, but it's a ratio of two quantities measured in different units. For example, miles per hour. Miles and hours are two different units, and that would be what we call a rate. A unit rate is a rate with a denominator of 1. So we might say you can type 28 words in 1 minute. So that is called a unit rate because it's per 1 unit. 1 minute, 1 hour, 1 day, 1 year, 1 foot, whatever. Unit analysis, also called dimensional analysis, is the process of selecting conversion factors to produce the appropriate units that you need. This is a fairly complicated system to do things, but when I show you how to do it, you'll understand what it's like. And a proportion is an equation that states that two ratios are equal. For example, 2 over 4 equals 4 over 8 is a proportion. 1/12 equals 4 over 48. That is also a proportion. Two ratios that are equal. All right. Now, you will need your calculator handy to make sure that you're understanding how to do this. And yes, you may use your calculator in this chapter. We talked about that before. This question says, Main Street florist sells 2 dozen roses for $24.60. Flowers for You florist sells 6 roses for $7.50. We need to find the unit rate for each and figure out which florist has the better deal. Now, whenever you're finding a unit rate and it deals with money, you always find the unit rate by taking your cost and dividing it by your size. Whether your size is in number, quantity, or ounces, pounds, whatever. So, if we're going to talk about Main Street, I'm going to do these in 2 different colors. Main Street florist, I'll do in blue. Main Street sells 2 dozen roses for $24.60. So $24.60 for 2 dozen. 2 dozen is 24 roses. Okay, because 2 times 6, or 2 times 12 equals 24. There's 12 somethings in a dozen. So if I take $24.60 and I divide that by 24, I'm going to get 1.025. And we should put the dollar sign there. Now, obviously, you can't have $1.02, because this would be saying $1.02.5 is basically what that's saying. Really, you can't have 2.5 cents, but for the intents and purposes of being able to compare these, we need to take it out that far for now. It would round to about $1.03 per rose, but we need to make sure that we're not confusing ourselves. So if we look at the next part of the problem, it says Flowers for You sells 6 roses for $7.50. So let's do that in green. So the Flowers place is $7.50 for 6 roses. So if I take 7.50 divided by 6 on my calculator, I'm going to get $1.25 per rose. I should have done that above here, should have labeled it per rose. So we found the unit rate for each, and obviously whichever one is the cheapest is which one is going to have the better deal, and Main Street florist has the better deal. So Main Street has the better deal. Because it's cheaper to buy their roses. Hopefully the roses are of the same quality. Okay, let's look at another problem. One brand of apple juice costs $1.56 for 48 ounces. Find the unit rate. Okay, remember, unit rate is cost divided by size. So in this case, that would be $1.56 divided by 48 ounces. If we put that in the calculator, 1.56 divided by 48, you're going to get 0.0325, or approximately 3 cents per ounce. It depends upon what they want the exact answer, or if they want approximately something. You could say 3 cents per ounce, or you could say 3.25 cents per ounce, even though really we don't have a quarter of a cent as a monetary value. They do, when they work things out mathematically for buying and purchasing and selling things, they do take it out to the nearest hundredth of a cent. Next problem here. In 2000, the 3,630-kilometer Tour de France was completed in 92.5 hours. Traveling at this speed, how long would it take to travel 295 kilometers? Okay, let's look at this. We have mileage and we have time. Time and distance. Okay, so my distance and my time. Okay. If we want to figure out how long it's going to take, we need to figure out how long it takes to do something in 1 hour. Okay, so if I have 3,630 kilometers, and it took me 92.5 hours to ride that, I can figure out how many kilometers per hour I was going. So if I take 3630 and divide that by 92.5, I'm going to get about 39.25 kilometers per hour. So if I'm traveling about 39.25 kilometers per hour, and I have to go 295 kilometers, I can take my 295 kilometers and divide that, or multiply it, in this case, you can do it this way, multiply it by 1 over 39.25 kilometers per hour. Okay, the kilometers are going to cancel out of the label, so if I take 295 and divide it by 39.25, it's going to take me approximately 7.51 hours, or about 7.5 hours. This next problem is going to talk about dimensional analysis, or unit analysis. The fastest recorded speed of an eastern gray kangaroo is 40 miles per hour. What is the kangaroo's speed in feet per second? So we need to change miles per hour to feet per second. You can't do these simultaneously. You cannot do them at the same time. You have to do them one at a time. So we have to remember a couple of things. And some of these things are things you may or may not know. So the first thing I'm going to do, if it's 40 miles in 1 hour, okay, I'm going to change my miles to feet. And it is helpful to know how many feet are in a mile. Some of you may know this, some of you may not know this. In case you don't know this, there's 5,280 feet is equal to 1 mile. How do I know that? I'm a runner, I know everything. But there's conversion charts. There are charts in your book. There are charts all over the place that tell you how many feet are in a mile. So if I'm going to multiply this, I'm going to multiply it by a fraction, because you always want to deal with a fraction, because you can tell when your units cancel out if you're doing something right. So it's 5,280 feet in 1 mile. I want the miles to cancel out. So the 5,280 feet will go on the top, and the 1 mile will go on the bottom, because now my miles will cancel out. If I would have put the miles at the top and the feet on the bottom, I wouldn't have had any conversions cancel out. Now I have feet. Notice I have feet per hour, but I don't need feet per hour. I need feet per second. So I've gotten down from miles to feet, but now I need to figure out how to get to seconds. I got to go from hours to seconds. So this is a better way of doing it than trying to figure out how many seconds are in an hour. Simply put, I'm just going to convert how many minutes are in an hour, and then how many seconds are in a minute, because that's the best way to convert. So how many minutes are in an hour? There are 60 minutes in 1 hour. Excuse me a second here, I did that wrong. Okay, there are 60 minutes in 1 hour. I need the hours to cancel out, so 1 hour will be on top, and the 60 minutes will be on the bottom. It has to be that way, because otherwise my hours don't cancel out. Now I now have feet per minute, but I need feet per second. So now I'm going to multiply by, there are 60 seconds in a minute. 60 seconds has to go in the denominator because I need the minutes to cancel out, so 1 minute will go on the top. Now those minutes have canceled out. So now I have this big long equation where I need to multiply 40 times 5,280. So if I do that, 40 times 5,280 on the top, I will get 211,200 feet in, if I multiply 60 times 60, that's 3,600 seconds. But I don't need to know how many feet I can do in 3,600 seconds. I need to know how many feet I can travel in 1 second. So I'll take 211,200 divided by 3,600, and I will get 58.6, repeating on my calculator, feet per second, or to be exact, 58 2/3 feet per second. So an eastern gray kangaroo can go 58 2/3 feet in 1 second. That's really fast. Next one here, our friend the sloth. A sloth is a very slow animal. He only travels at 0.15 miles per hour. We're going to figure out how fast he moves in feet per minute. So we're going to go from miles to feet and hours to minutes. So that's what we're going to look at. So if I start here with 0.15 miles per 1 hour, I'm going to convert my miles first. If you remember, there's 5,280 feet is equal to 1 mile. So I need my miles to cancel out, so my 1 mile will go on the bottom, and my 5,280 feet will go on the top, because now the miles have canceled out, and I've got feet per hour, but I need feet per minute. So I've gotten my feet taken care of. Now I need to do minutes, and there are 60 minutes in an hour. There are 60 minutes equals 1 hour. I need my hours to cancel out, so my 1 hour will go up here, and my 60 minutes will go down here, the denominator, and the hours cancel out. So now I simply need to multiply straight across the top, 5,280 times 0.15, and that'll give me 792 feet in 60 minutes. But I don't need to know how many feet I can go in 60 minutes. I need to know how fast the sloth is traveling in 1 minute. So take your 792 and divide it by 60. And you will get 13.2 feet per minute. Not all that quick. This ends part 1 of lesson 3-4.